States of matter. The essential question, what are the four main states of matter? And we're going to talk about their definitions and some examples and their properties. Matter, to review, is stuff. It's what things are made out of. Matter has mass, and it takes up space, and it's made out of atoms and molecules. Even things like air that we can't see is matter. It's made out of atoms and molecules. And if we put it in a balloon, for example, the balloon expands because that air is taking up space. The first state of matter that we're going to talk about is solids. Solids have a fixed volume and a fixed shape. Fixed means that it doesn't change. So if I take a solid, ice for example, and I put it into a container, then its volume and shape is not going to change. It's just going to sit in the container as long as it stays solid. Okay, the table's a solid, the pencil you're writing with, your paper. The next state of matter is liquid. Liquids have a fixed volume, but it takes the shape of its container, so it does not have a fixed shape. If I have a liter of water and I pour it into a different container, it's still a liter of water, but it will have a new shape depending on what its new container looks like. Examples are gasoline, and I put this example on here because when we talk about liquids and gases, students sometimes confuse gas, the gas that's in the air you breathe, for example, with gasoline, which is a liquid that you pump out of the pump at the gas station. Okay, soda pop that you drink is another example of liquid. Okay, and the next state of matter is gas. No fixed shape, no fixed volume, and it expands to fill its container. So gases will spread apart as far as they can until something contains them. And they'll take on whatever shape their container is. The fourth state of matter that we don't talk about a lot is plasma. And plasma is just a superheated gas. So examples of where you would find plasma are in stars, like our sun is a star, and fluorescent lights. So the fluorescent lights over the classroom are filled with plasma. And our final slide, you have this right here in your notebook. So go ahead and write down the page number where you find this in your notebook. That way you can refer back to it as you're studying your notes. And this is our phase change diagram. Okay, it goes along with the PhET simulation that we've been using in class. It's also on Blackboard. So this shows that as you add energy, more energy causes the molecules or the atoms in a substance to speed up and get further apart. So more energy equals more speed and more distance. As you remove energy, okay, which is heat in this case, as you remove energy, the particles slow down, so you have less speed, and they get closer together. And I think you guys know this. So you have a solid, the particles are packed closer together, they're not moving very fast, they're shaking, and they are moving, but they're not moving past each other. As you add heat and energy, then the particles start to move faster, they start to spread apart until they begin evaporating into a gas. And we'll talk about the phase changes in the next lecture. But just to kind of sum things up here and help you remember, if you can remember, solids are slow, liquids flow, and gas is fast.